My dear grade 4 students of Sheikh Abubakar Gumi Academy. Assalamu alaikum. I hope you are doing very well and keeping safe. Welcome to our second online tutorial, and inshallah we are going to be taking a look at area of a square. Inshallah, area of a square. And after this, we'll try to see some word problems that could arise from this topic, and also from what we did last time, which is the area of a rectangle. Remember? Yes. So inshallah, we are going to see the area of a square. And from my definition in our last class, I told you that area is a measure of the surface of a shape. Okay? A measure of a surface of a shape. So quickly, let's see. If I have a square, as you all know, a square has a uniform length all around, meaning you realize that the length from this point to this point is the same as the length from this point to this point, which is also the same as that from this point to this point, and then also from here to here. It means they are all the same. For that reason, they are all referred to as side, or you can call it length. Okay? It means they all have the same measurement or the same magnitude in terms of the dimension. So let's look at it now. If the area is defined as length times length, or as you will see in some textbook, the area is what? Side times side. And the unit is usually in either centimeter squared or meter squared or any other unit used in the measurement of length, but a square of it, depending on the magnitude of the square. Okay? Because we are only looking at a smaller one, but there can be larger squares that could even run into kilometers, and in such cases you say kilometer square. So let's look at it now. Inshallah, having known this briefly, we'll take examples. Right? Example 1. Find the area of a square with a length of 6 centimeters. Find the area of a square with a length of 6 centimeters. Now, if this is the case, easily, the solution to the problem, I've been given the length as what? 6 centimeters. So I know the length is what? 6 centimeters. So the area is given as length times length. And if you put this, you realize that the area is going to be what? Substituting the value for the length straight into the formula, I'll have 6 centimeters times another what? 6 centimeters. Meaning length times length, 6 centimeters times 6 centimeters. When you multiply this, now you will get 6 times 6 is what? 36. Now centimeter times centimeter will give me what? Centimeters squared. I hope this is clear. Yes. Let's quickly take another example. Example 2. The length of a given square is 7 meters this time around. find its area. All right? Let's see the solution to this problem. The solution, you see, in some questions, you could be asked, okay, this question could be rephrased as, find the area of a square whose length is 7 meters. It's still saying the same thing. The length of a given square is 7 meters, find its area. Same thing, okay? Just question technicalities. Now, the solution, I have my length as what? 7 meters. So the area is what? Length times length, or side times side, as you may see in some other textbooks. You see, the area will be what? 7 meters multiplied by what? 7 meters. And 7 multiplied by 7 is what? 49. I start with the figure 7 times 7, which is 49. Then meter times meter will give me what? Meter squared. I hope that is taken. Okay? Then there are instances at which you will be given the area and asked to find the length. Okay? Just like we observed in what we did last week while we were looking at the rectangle. Okay? In an example like this, the area of a particular square is given as 25 centimeters squared. Okay? You could use different perfect squares that will amount to us getting the exact answer. So, if I am using, I could use 25, I could use any of the perfect squares. I believe you remembered your perfect squares very well. A number that is obtained by multiplying two similar numbers. Okay, we may decide to even use 16, for example. 16, okay? The area of a particular square is given as 16. Okay? Now, find the length. Yes, find the length. We use 25, 16, 36, and so on. This is indicative of the fact that the length of a square are the same all true, because it's only the same figure that will be multiplied by itself to give us the area. So let's see the solution now. Solution to this problem. I have the area A to be given as 16 what? Centimeters squared. Now the length is unknown, and I know that my area is what? Length times length, or area is length squared. I hope we are together. Now, how do I do this? I substitute this value directly into the formula, having known that my area is 16 centimeters. So therefore, since my area is length squared, that means 16 centimeter squared is equal to what? Length squared. Now, in situations like this, if you have a figure, okay, being equal to an unknown square, what you are supposed to do is to find the square root of both sides. You find the square root of both sides, you'll be able to determine the value of length. So that is what you do. Now you take the square root of both sides. Okay? You see, this square will be cancelled by the square root. So what you will end up getting is the square root of 16. And what is the number that will be multiplied by itself? Which number could be multiplied by itself to get 16? A number that will be multiplied by itself to get 16. If you do it on your textbooks or on your notebook, you realize that it is 4. But similarly, we can still attempt to find it using the manual method, which you have actually been taught earlier. If you want to find the square root of 16, the first thing you do is you conduct prime factorization. You express it as a product of its prime factors. Then you group them into two groups, since we are talking about two similar numbers multiplying each other. What happens here is I have what? 16. The smallest prime number that could divide is what? 2. 2 divides 16 8 times, right? The next is still 2. 2 will divide 8 4 times. The next will still be 2. 2 will divide 4 2 times. The next will still be what? 2. 2 will divide 2 once. So if you look at this very well, I can group this into 2 different groups. I can say this is group 1 and this is group 2. So I have 2. I put the first 2 here. I have another 2. I put the second 2 here, right? Times the other 2. I put it here. The next one I'll put here. If they are more than this, that's how I'll keep arranging them in the 2 different brackets until I exhaust all the factors that are obtainable on this table. So what is happening here is that I'm going to have what? 2 times 2 is what? 4. 2 times 2 is what? 4. This means that if you multiply 4 by 4, you will get 16. Therefore, I have 4 centimeters to be the square root of 16 centimeters squared, which is equal to my length. That means the length is 4 centimeters. I hope that is taken. Okay? So I'm going to give you an exercise now, inshallah, so that you'll be able to attempt it and see how much you have understood these examples we have done just now. Okay? As grade 4 students, you should always try to work out more questions. Okay? Exercise. We have number 1. Find the area of a square whose length is given as 3 centimeters. Okay? Question 2. The area of a particular square is given as 64 meter squared. Find its length. Okay, find its length. So that will be all for now, inshallah. Still within this week, we are going to be taking a look at the other aspect which I talked about earlier, inshallah. See you then. Thank you.